Bismillahirrahmanirrahim. Assalamu alaikum. My name is Mary Akhtar, and today I'm going to represent practical 2. The topic of this practical is the percentage of carbon dioxide in the cold drinks. So, first, I'm going to talk about the traditional method for the calculation of the carbon dioxide that are present in the soft drink or cold drink. Then I'm going to talk about the very advanced method. So, the practical is determination of the amount of the free carbon dioxide that are present in the given sample of the cold drink. So, carbon dioxide is a very major component of the atmospheric gases and a byproduct of the aspiration. It is present in the groundwater. Usually, the concentration of the carbon dioxide is below 10 milligram per liter. The analysis of the carbon dioxide involves the titration using the phenolphthalein indicator and a standard solution, which is sodium hydroxide. So it is two-step. In the first step, hydrogen carbonate is formed, and then it's react with the additional sodium hydroxide to form the carbonate ion. There's the reaction here. We can see that, and the conversion of the bicarbonate ion is a complete and at the pH of 8.3. So let's move towards the apparatus: Allen-Meyer flask, pipette, beaker, marine cylinder, burette, weighing balance, volumetric flask. Chemicals and reagent include phenolphthalein indicator, cold drinks, and 1 molar NaOH. In this procedure, we have to take the sodium hydroxide in a clean beaker, and we have to rinse the burette and drain it into the sink. The rinse drain the period bed of the sodium hydroxide solution. Some of the solution are followed through the tip of the bubbles. Fill the burette with the standard solution of the solution. And after that, use a clean stirring rod to remove for the extra shaking of the extra carbon dioxide. Add 2 to 3 drops of the indicator solution that are added into the flask. Now use titration technique simply such as the acid-base titration, and thus titrate it. When the pink color is obtained after the shaking, this is called endpoint of the titration, and similarly 3 readings were taken to minimize the error. These are the observations. We took 3 readings in which volume of the NaOH and volume of the sample. Then we calculate it, and the result will be 6.6 gram of the carbon dioxide per liter of the cold drink. Now I'm heading towards the current method. Here we are also calculating the free carbon dioxide that are present in the cold drink, but by using the carbo-QC method. Carbo-QC method uses supply of air or nitrogen data collection system and optional. Test procedure include turn on the pressurizing gas, regulate the outlet pressure to reach 87 psi, gently lock the sample back for it, turn can upside down, pull the safely shield down to the base, turn lever clockwise and pierce the sample, and after that, press the start button on the measuring unit. When the carbon dioxide value is displayed on the screen, record data or press print. Raise the sample tube to the top. Raise the sheave to save yourself. Now, this is the second method and here we use carbon dioxide analyzer equipment. Here we are also using carbo-QC method, pressurizing gas or nitrogen or air either from the house supply or elsewhere. Data collecting system, and the reagents are protein removing detergent for weekly cleaning of the instruments. Safely, we use safety goggles and other equipment that analysts think is necessary for this procedure. These are the equipment, and for the sample preparation can be analyzed at temperature between 40 to 70 Fahrenheit. Bottom must be cool to 47 degrees Fahrenheit. This is the flow chart of this carbo-QC method, in which we are going to calculate the free carbon dioxide in the cold drinks. Turn on the air or nitrogen, and the pressure will be of 87 psi. Cool bottle to 40 degrees Fahrenheit and cans to 40 to 70 Fahrenheit. Rock sample gently back and forth 15 times. For the can or a glass, this is the container type, PET bottle or a can or a glass. For can or glass, remove PET bottle, invert if can, replace the glass bottle on the piercer base and adjust the height of the piercer. PET bottle. For the PET bottle, fix the PET bottle adapter to piercer and place the bottle adapter. And then this is the same procedure for the both. We have to start the button, press on the mirroring, and then when the carbon dioxide volume is displayed, record the result, raise sample tube, and that is how we can calculate it. For the can between the 40 degree to 70 degree, remove the PET bottle. This is the written form from the flow chart for the PET bottle and the can bottle. This is the flow chart for the both. Carbon dioxide gas, this is the second method. Carbon dioxide gas volume aromatic method. The purpose of the aromatic tester, here we are using aromatic tester to determine the amount of the carbon dioxide in the beverage sample. For the equipment, ultrasonic test unit, mechanical shaker. Optional is dead weight pressure gauge tester or a master certified gauge. National Institute of Standard and Technology or equivalent certified thermometer for the temperature calibration. Everything must be calibrated for the error-free calculations. Equipment preparation, calibration per manufacturing instruction. Ensure all the aromatic tester settings are correct. Sample preparation is sample should be unopened, finished product container. Customize your own test procedure by combining all the key elements by the handshake method and automatic test unit manufacturing instruction. Adjustment are required for the altitude effect and can be programmed into the controlling computer, if so equipped. A wait of 30 seconds after the sonification or mechanical shaker is necessary. This is the handshake method, in which the reagents include calibration check standard, treated water for cleaning, distilled or deionized water for the checking standard. Test procedure for the bottles. Select the bottle at random and adjust temperature to 4 degree to 2 degree. Equilibrate the sample by gently inverting 15 times in 30 seconds. Do not shake for back and forth, nor up and down. Wait for the bubble to clear the liquid. So now place the bottle under the tester, close the sniff valve, pierce the crown, and keep thermometer above the liquid. Raise it, and this is how target sniff pressure must be equal to 20 beside a plus altitude correction factor. Hold the button of the tester pad in one hand and the crossbar in other hand. Record maximum pressure and temperature reading. Adjust the pressure reading with the altitude correction. Open the sniff valve vent until the pressure is 0 before removing the bottle. This is the test for the cans. And now I'm heading towards the third method, which is the gas volume sample measure. In this equipment, mechanical thermometer, mechanical pressure gauge, piercing needle standard, nut gasset, rubber seal. This is the diagram of the carbon dioxide tester, complete with the dial thermometer and pressure gauge. This is the dial thermometer dual scale. The reagent are carbotabs, citric acid, anhydrous, distilled or deionized water, treated water, light oil. Test procedure for the cans. Select can and random. Close the sniff value, grasp the lock, pierce the can bottom by forcing the crowbar down, and then push the thermometer into the can as far as it will go. Hold on the tester pad in one hand and the crossbar in the other hand. This is how corrected pressure is equal to gauge minus altitude factor. Convert pressure and temperature to the gas volume using carbonation volume charts. Round to the nearest 0.0 reading. Open the sniff valve vent until the pressure is 0 before removing the can from the test. That was all for the calculation of the free carbon dioxide from the given sample of the cold drink or soft drink. That was all from my side, in which I have discussed the traditional method and the current or the latest method. Thank you.